Good day, everyone. Welcome to my class. This is your teacher, Mr. Herman M. Soriano, Junior the Second, your math teacher. Welcome again for a new episode of Math Amazing Lecture. And for this time, we will be learning about the normal distribution. Our learning objectives for this session, you are expected to first, illustrate a normal random variable and its characteristics. And lastly, identify regions under the normal curve corresponding to different standard normal values. The normal distribution is simply the normal curve is bell-shaped distribution, which has important role in inferential statistics. It provides a graphical representation of statistical values that are needed in describing the characteristics of population as well as in making decisions. Many events in real life generate random variables that are either normally distributed or at least approximately normally distributed, like heights, weights, examination scores, salaries, opinions, or votes, and etc. The normal distribution refers to a continuous probability distribution described by this normal equation. A random variable x whose distribution has the shape of a normal curve is also called the normal random variable. This random variable x is said to be normally distributed with mean and standard deviation. Now, let's have the properties of normal probability distribution. For number 1, the distribution curve is bell-shaped. It looks like this. Number 2, the curve is symmetrical about its center. So, from the center, the left part and the right part are symmetrical. And for number 3, the mean, median, and mode coincide at the center, meaning the three measures of central tendency lie at the middle of the curve. And for number 4, the width of the curve is determined by the standard deviation of the distribution, meaning the standard deviation will determine how wide or how narrow the graph of the curve is. For number 5, the tails of the curve flatten out indefinitely along the horizontal axis, always approaching the axis but never touching it. That is, the curve is asymptotic to the baseline. And for number 6, the total area under the normal curve is equal to 1, or in percentage it is equal to 100%. This means the left part corresponds to 50% of the whole area, so with the right part. Now, there are two factors that the graph of the normal distribution may depend on. For number 1, mean determines the location of the center of the bell-shaped curve. Thus, a change in the value of the mean shapes the graph of the normal curve to the right or to the left. Number 2, the standard deviation determines the shape of the graphs, particularly the height and the width of the curve. A large standard deviation and variance means that the distribution is rather spread out with some chance of observing values at some distance from the mean. Large value of standard deviation makes the normal curve short and wide. Moreover, small values of standard deviation yields a skinner yet taller normal distribution. A small standard deviation and variance means the distribution of the random variable is quite concentrated around its mean. Now, let's also discuss the standard normal curve. What is standard normal curve? A standard normal curve is a normal probability distribution that has a mean equal to 0 and a standard deviation equal to 1. It makes life a lot easier for us if we standardize the normal curve. We can transform all the observations of any random variable x with the mean and the standard deviation to any set of observations of another normal random variable z with mean equal to 0 and a standard deviation of equal to 1. Every normal curve, regardless of its mean or standard deviation, conforms to the following empirical rule, also called the 68, 95, 99.7 rule. For rule number 1, about 68.26% of the area under the curve falls within one standard deviation from the mean. And for rule number 2, about 95.44% of the area under the curve falls within two standard deviations from the mean. And for rule number 3, about 99.74% of the area under the curve falls within 3 standard deviations from the mean. And lastly, let's also discuss about areas of regions under the normal curve. To find the areas of the regions under the normal curve that correspond to a z value, simply find the area of the given z value using the z table, also known as the table of areas under normal curve. It is a chart or table that looks like this. Now, to understand further the lesson, let's have example. For example number 1, find the area that correspond to each of the following z-score values. For letter A, z is equal to 0.6. Now, there are 3 steps in finding the area that correspond to a z-score value. Step number 1, express the given into 2 decimal form. And it is z is equal to 0.60. For step number 2, in the z table, let's find the row z is equal to 0.6 and a column heading 0.00. For step number 3, the intersection of 0.6 and 0.00 is 0.7257. Thus, the area that corresponds to z is equal to 0.60 is equal to 0.7257. Next, for letter B, find the area that corresponds to z is equal to negative 1.47. Now let's apply the 3-step rule. Step number 1, express the given into 2 decimal form. And it is z is equal to negative 1.47 as it is. Step number 2, in the z table, let's find the z is equal to negative 1.4 in the row and in the column with the heading 0.07. Now, for step number 3, the intersection of the row and the column, z is equal to negative 1.4 and column 0.07 is 0.0708. Thus, the area that corresponds to z is equal to negative 1.47 is 0.0708. Let's have another one. For letter C, find the area that corresponds to z is equal to 2.13. Now, let me ask you, for step number 1, expressing the given z value score into 2 decimal form. What is its 2 decimal form? Yes, you are right. It's as it is. It's 2.13. Now for step number 2, let's use the table and let's find the row with z is equal to 2.1 and a column with heading 0.03. So 2.1.03. What is the intersection? Yes, the intersection is 0.9834. Now what does it mean? Yes, thus the area that corresponds to z is equal to 2.13 is 0.9834. That ends our lecture. Happy learning!